It's for you.
Family manager. Every morning I got writing, reading, listening.
Yeah, it's great.
It's not.
Continue. Yeah? You got this, Ben? Ben, let's go.
Electromotive.
Yeah? Okay. Got that? Sorry. Couple of things. Relax. Right, so potential difference, PD, is just another name for voltage. So, just so you know, really, if I have a resistor like this, and this here is 10 volts, a lot of time people just say the potential difference, the PD, is 10 volts. Just means here, the difference is 10 volts. That's all. It's the same as voltage, really. Potential difference is another name for voltage, so if you can write that down. Yeah, you got that? You got that, yeah? Yeah. Electromotive force, also called EMF. Now let's try and work this out. What does the word electro mean? What's it sound like? Electro. Electricity. Like this. Motive?
Motivation.
Action. Motivation. Yeah. And force? Force. So put it together. Electromotive force. Come on.
Electric energy makes makes something move.
Yeah, okay. Not too bad. So it's the voltage developed by any source of electrical energy such as a battery. So if you have a battery, it makes a voltage. How does it make a voltage? It makes a voltage because it has an EMF.
EMP.
Not EMP, that's different. EMF. Basically, it's the electric potential source in a circuit. A device that supplies electrical energy is called the seat of the electromotive force. EMFs convert chemical, mechanical and other forms of energy into electrical. So look, let me try and explain with the battery here, okay? So this battery, if I connect a voltmeter, it has a voltage. Why does it have a voltage? Because it can convert chemical energy into electrical. Because this battery is, what is it made of? It's made of something. Cadmium. Some batteries are made of lithium. It can change the chemical energy into electrical energy. So we say it has an EMF. The EMF is what makes the voltage. Do you understand? It's like the force that makes the voltage from the chemicals. For the exam, you only need the first sentence, okay? So just write down the first sentence is enough.
It's the same as last Friday we declared the EMF.
Yes.
missed that class.
Yeah, you shouldn't have, because I told you we'd have class on Friday.
No, I missed the whole day's class.
The whole day.
Yeah,
Not nice.
yes.
I bet he didn't even watch the YouTube video.
Pardon?
Did you even watch the YouTube video?
I think we both of us don't know we have class on Friday.
But you were there on Friday. He wasn't.
So I'm already in the bus stop, and Ben told me we have class, and I run back.
Funny.
For me, if I don't,
If you didn't say anything, she'd be home.
Yeah.
All right, continuing.
okay.
Okay. So what's the difference between EMF and potential difference? Not much. For example, we say an EMF of 1 volt means each coulomb of charge is given 1 joule of energy, whereas a potential difference of 1 volt means each coulomb could do 1 joule of work. So it's only English, all right? This gives energy. So we say EMF. EMF is maybe 1 volt. But, you know, something like my phone takes energy. So we say potential difference 1 volt. So the potential difference should equal the EMF. You know, the EMF is the voltage given, the potential difference is usually the voltage taken. Do you understand? Summer? It's okay? Are you sure? It's okay? So look. EMF or PD?
Yeah,
EMF. Well, if it was a battery. I should really say, like, this, an EMF is inside of this. Yeah? Continue? Basically, EMFs gives a charge. Anyways. Okay, so look. Here is a very, very important circuit you need for the exam. When we picture a battery, there it is there. This is 1.5 volts. Okay, it's like an AA battery. You notice that this battery, yeah?
No.
No. You notice that this battery sometimes gets a little warm, if you feel it, right?
yeah.
Yeah. So what we imagine is that this is like you have some perfect cells and a small resistance here. Now it's not really like this, okay? Because you don't want this. I'm just saying we imagine it's like this, that it has 2 parts. It has a perfect part and a small resistance. And we don't want this, but we can't get rid of it. Do you get what I mean? Like, I imagine it's like this. It's not really like this. Okay? So, this part here is the perfect part, the EMF. And then this part here is the OR. Okay? Is that okay? Yeah? Okay. Now, what I do next, I'll connect this up to a variable resistor. And I'll connect it up to an ammeter here. And I'll also put a voltmeter. Now you can put the voltmeter here, or you can put it here. In both cases, these would be the same anyways. Where would you prefer it drawn? On the top or the bottom? Yeah, me too. In the exam, they usually draw it on the top, but it's the same as on the bottom. Okay? So we'll just, I'll keep it the same as the picture here, and I'll put it on the top. Okay. Now, if I use the loop rule, Kirchhoff's loop rule.
Mm.
We can start here and we'll go around this way. So I start off with E minus, yeah, now this one changes. Yeah, but this one is the same as V.
Yeah.
So I could just write E minus V. Yeah? And then minus, and then I get here, minus I or equals 0, which is that. That's fine. So I could change that into V equals I or minus E. That's the formula there. And that formula is useful because we can know this, right? Because there it is there.
Yeah.
What else can we know?
EMF.
No, we can't because that's inside.
Okay.
So we can't know it, it's hidden. What could we know also? The I. We can know the I.
Oh, yeah.
Do we know this? No,
No.
it's inside. We don't know it. This is hidden. You know what I mean? Hidden. You can't see it. Do we know this?
No.
No. But if I make two equations, then I can figure out the or and the E. Do you know what I mean? I need to make two equations. So that's why I need this guy, so I can change it. Make two equations. You understand? Yeah. What you could also do, well, maybe I should go on to the next page here. You can also make a graph. So this is choice 1. Choice 2. You could change this into V, or as it's like y equals mx plus c, where this is I and this is V. What will the shape look like? Oh, I'm sorry, I think I did something wrong here.
E minus I or.
V equals, oh, I have it backwards. Sorry, that's a minus and that's a plus then, yeah. So you could make a graph and the graph would look like this. What would this represent when the I is 0? What is that on the graph?
In the beginning, that.
Yeah, that would be E. And what would the slope here be? Yeah, no, because I is here. I is like X. Yeah, be minus or. Yeah. So you have two ways to get the mystery E and the mystery or. You can either use this equation twice, or you can get it from a graph. This is difficult. So you need to copy this in your notebook. The two methods. Where the heck did Khalifa go? He left half an hour ago. No, 20 minutes ago. No, 25 minutes ago.
We don't know. Where is Khalifa?
Oh, I'm so hungry.
So tired.
Slope equals V, oh, E
slope equals minus R.
E per equals,
Exhausted.
Yeah, I know. Continue. So look, we have just two questions.
Good.
Just two. Okay, it's not so difficult. What I'll do is I'll do the second one first because it's a little easier. So you have a battery. It has an EMF of E and internal resistance R. We don't know the E and the R. Okay? When you have a resistance here of 2 ohms, the current is 500 milliamps. And if you change the resistance to 3 ohms, the current reduces to 400. So when this is 2 ohms, we get, what did I say? 500 milliamps. And then if you increase it to 3 ohms, you get 400 milliamps. Now if I use this formula, I can get the R and the E in the battery. So I can say V, do I know V? No, I don't know the V. So I have V equals E minus IR. Okay, I don't know E. What do I know? I know the I. Okay, and I know the R. So what you should do is you should get the V. You could just say V, yeah, V equals IR. Okay, so for the first one, what's the V? 2, it's 1. 2 multiply 0.5. E minus 0.5 R. Okay. And what's it for the second one? V equals IR 1.2? 1.2 equals E minus 0.4 R. So together, I can get 0.2, 0.1 R. Yes. So R equals 0.5. Sorry. Let me try that again. R equals 2. And E would equal, that's 2, that's 1, 2. Yeah? Okay, so that's my first example for this. And then we'll do another example in a moment.
how to get a minus?
Khalifa, what happened to you? You've been gone for half an hour.
I still.
Come on.
It's been.
How to get minus R?
Minus or?
Slow.
No, I use this formula.
How?
E minus IR.
Minus R. So what? How to get minus R?
What do you mean, how to get minus or?
Yeah.
What do you mean?
Slow.
No, I'm not using this. I'm just using this.
Is it?
I use this twice to make 2 equations. You're confused. Yeah?
Is this is the same current looks like, so I don't have to write on question.
No, it's the same picture, yeah.
Yeah.
The picture's always the same.
Okay.
What's wrong, Ben?
You say the teacher's slope is minus R.
Yeah, but that's for this one. For this one, you can just use this equation twice, 2 times.
I know.
Yeah. Yeah.
I just question how to get minus R.
Ah, you can't. But you can get the slope. So if you prefer, you can say R equals minus slope. You don't know this, but you can know this.
Okay.
Yeah, it's impossible to know this because it's inside.
Okay.
Continue. Go. Do you write this down? Yeah. Is okay?
Yeah.
Are you sure?
Yeah.
Are you very sure?
Yeah, I'm very sure.
Okay. I don't trust you, but okay.
Okay.
Right. Next one. So, a circuit is set up as shown, and you measure the voltage and the current. Let's make the graph here. So, if you were to do this graph, you put current here and voltage here, right? Then what you would get is a shape like this. Whereas this guy here would be the EMF, and you can get the R is minus the slope. Yeah? So let's graph this. What's the first current? 0.1 is 1.9. Okay, so 0.1 is 1.9. So that would be there. And what do you think is going to happen? It's going to go down and down and down and down. And the last one is 1 is 1. So here at 1, we finish there at 1. So if you draw this graph in the exam, what you do is you extend it back to here on your graph paper, and you'll see that this will be a 2. So the EMF is 2. Then, to get the R, you need to draw a triangle and calculate the slope. So how big is this side?
1.
1. And this side?
4.
1. So the slope is minus 1 because it's going down. So that means the R is 1 ohm. So now I have the R and the E. Yeah?
YR. So here YR equals minus slope.
R equals minus slope, which here
Okay.
equals minus minus 1.
I know how to get this.
This?
Yeah.
Yeah. So the rule is,
No, I know this.
you know this.
R equals minus slope.
Oh, how do I get this?
Yeah.
Ah. Okay. Right, you have V equals E minus IR. You're happy with that?
Yeah.
That's okay, alright. So V equals minus R times I plus E. But Y equals MX plus C. So, what's wrong? It's okay? Be strong, Tau.
I just died for 1 minute.
Just for 1 minute. It's okay? It's difficult, I know. So, graph done. Or done. EMF done.
Also,
Now, yeah?
we only need to draw these and we can calculate.
That's all. So this is a good question in the exam. You know, in the exam, they'll first say, draw the circuit. Look, here's the circuit. Look. First they'll ask you to draw this. Easy peasy, right? Then, they'll give you this data and ask you to graph this. Then, they'll ask you for the OR. Then they'll ask you for the E. It's like 10 marks.
Wait, what's that R is in the battery? Or the
Yeah.
big R?
No, in the battery.
The small R,
Internal.
internal.
Internal. What's the other one called? External. Internal, external. Inside, outside.
Okay.
Yeah?
Okay.
Yeah? This is okay.
So this time we'll say on the laptop
What?
at the exam. I mean.
No, what I'm saying is, this question comes up in the exam. This one is what it's like in section A. They give you 2 equations, you solve, you get the OR and the E. In section B, it looks like this.
So you need to draw.
You need to draw a beautiful graph. A beautiful graph. And then you need to find this and this on the graph.
So will we do this on laptop again? Or by hand?
In the exam? By hand, of course. Is it? Is it?
Is it?
I'm asking you, is it okay?
It's okay. It is okay.
Okay, now I believe you're right. Fine. So, how many questions did I give you there for this one? Just 2. The first one is like section A. The second one
Okay.
is section B. There's loads of time. Right. You can try these 2 now.
Okay.
Oh, come on. Be strong, girl. We're nearly finished. We only have 1 lesson left and then we can do revision.
One lesson left.
1 lesson left.
So we have time to recap.
Yes. Be strong. Okay?
Is replaced with a 1 ohm resistor. What's that mean?
A 2.1 ohm resistor is connected.
Yeah.
Yeah, in the picture.
Yeah.
And then, I can't believe you're asking me this. Where does it say? Here. Then the 2.1 ohm is replaced with 1 ohm.
Yeah.
Yeah?
The under this one is the 1 ohm, and this one.
Yeah? It's 2.1. And what do you do?
But
Make two
actually, we don't know the internal resistance.
I know, that's what I'm asking you to find. Summer! Summer! It's like what we did here.
Oh! I thought the first one is the internal resistor.
No, because
why you give me the unknown resistor?
Because you can't know this. It doesn't really exist.
Yeah, I know. Yeah.
Like, okay,
Yeah,
not
yeah.
really
Yeah.
there.
Yeah, I'm strange. Why you give me the?
You are strange.
Yeah.
You're very strange.
Sorry.
EMF sensor mechanical formula, right?
Say again?
Which EMF? Mechanical formula?
Use the formula, yeah, for the question 1. You got an answer?
Yeah, it's full. Whole number is great.
Is it right? Check. What did I ask you first? For the OR?
Or
What did you get?
19.
That seems very big. The OR is usually a small number.
I just take them inside here. They're just simple equation. Something wrong? Those.
Did you do this minus this, is it? Okay, maybe it's my mistake. But, where's my book? Maybe I'm wrong.
What are you?
Maybe I'm wrong. English!
Wait,
Please.
you're not speaking.
Oh, sorry,
anything.
I'm sorry.
We just.
This one. And this one. Is
It's
0.378.
Can I see?
Wait,
hang on. You don't know the V.
Yes, so we calculate
You calculate it.
I put the wrong.
The wrong V.
The wrong
Yeah,
number.
there you go. Okay, that's better.
21.
For what?
The resistor.
No.
No? 0.1. Maybe here the ohm.
.36. Why .378? How'd you get the 378?
It's 2.1 ohm and 0.18. IR equals volt.
What are you doing? I can't make it out.
The
No, here, okay.
yeah. Maybe I
How?
think
No. How did you get this 378?
this 3
Yeah.
Oh, sorry. I went wrong. Sorry. My mistake.